The law of sines formula is a little bit simpler than the law of cosines formula. So if you remember, you use law of sines. I'm going to write these letters out here. So this side would be A, this side would be C, this side would be B. You use law of sines if you know an angle and a side that are across from here, and you're trying to find either an angle or a side where you have one of these. So you use law of cosines when you're trying to find a side or an angle, but you use law of cosines when you have a side angle side situation. So this is what it looks like. If you know this side's 8, this side's 10, and you know this angle's 23 degrees, and you're trying to find this side. This is a side angle side because you know the angle in between the two sides that make it up. Or I could ask you, you could be given this side right here, 12, and you would try to find this angle, x, by using law of cosines. So the formula for law of cosines is a squared is equal to b squared plus c squared minus 2bc times the cosine of angle A. So the angle that you have is always opposite of the side length. The angle that you're talking about is always opposite the side. It doesn't matter how you set up the letters. If I have b squared, then this is going to be cosine of b, and this is going to have to be a squared and c squared and ac. If I have c squared, this is going to have to be a and b, and the c is going to have to be over here. This is going to be a and b. So it's not really about the letters, it's about the positioning of the sides and the angles. So if I look at this first example, I have a side angle side. I have an angle in between two sides, and I'm trying to figure out, these two are stars, and I'm trying to figure out the distance between here. This angle corresponds with this side, so I'm going to go ahead and write in the letters A. Well, I just had to write an A, I guess. So I'm trying to find side A. It's opposite the angle. It doesn't matter what formula I use up here. I'm going to write the first one down. So don't get so caught up with the A, B, and C because each A and B, C could be separate or different on an actual diagram. So I'm going to write A squared equals B squared plus C squared minus 2BC cosine of angle A. So A squared is a side that's opposite of the angle I know. So that's A squared equals B squared and plus C squared. So these two are interchangeable. I could have labeled this C or this B, it doesn't matter. It makes up the angle. Minus 2 times 9.5 times 4.6 times cosine of 43. This is a long expression here. So all you're going to do is, if you're trying to find the sine length, if you have A squared, to get A by itself, you need to take the square root. So in your calculator, you can do this all at one time. I'd rather you do it one time than to have multiple roundings. So you do A is equal to this, the square root of all of that in your calculator. And the answer is going to be, we're talking about distance, and we're using terms of light years. So it's going to be light years, and you're going to have some rounding. So I'm going to use approximately. Okay, second example. The lengths of two sides of a triangle are 8 and 10. The measure of the angle between them is 40. Find the length of the third side. So we're going to let that be x. So again, I'm going to use the formula for law of sines because I have a side angle side situation. So it's going to be a squared plus b, oops, erase that here. So a squared plus, I did it again. a squared equals b squared plus c squared minus 2bc cosine a. So my a, or my b and c are going to be these two. The side that's opposite the angle is the side that's opposite the equal side. So it's going to be x squared equals 8 squared plus 10 squared minus 2 times 8 times 10 times cosine of 40 degrees. So in order to solve for x, you got to x squared again. So you need to do the square root. So put all this in your calculator, square root. And the last example. I'm going to do a lot more in class, but the last example. Draw a triangle, RST. Side S is opposite side T is 41. Side T is 53. Angle R is 126. Find the measure of angle T. This measure. Okay, so I'm going to walk through this here. So I'm trying to find an angle measure, this angle T. So I'm thinking about law of cosines since we're going over right now. In order for doing law of cosines, I have a side, angle, side, and I would need to find this side. So that's not giving me angle T. So I think about that. Not going to do that yet because that would involve more steps. So now I'm going to see law of sines. Can law of sines help me find this angle? So when I do law of sines, I know this side that's opposite the angle, but I don't have another angle with a side that we know opposite. I know this angle, but I don't know this side. I know this angle, but I do know this side, so these two don't match up. So actually what I'm going to do is I'm going to do law of cosines to find what R is. And once I know what R is, I can use law of sines to use these two together, and then I'll do these two together. So it's two steps here. So the first step is I'm going to do law of cosines. So it's going to be R squared, because that's the side that's opposite the angle I know, equals 53 squared plus 41 squared minus 2 times 53 times 41 times cosine 126. So remember, to solve for this, I have to take the square root of this number. So I'm going to hold that number, don't know what that number is, and this is what my R is going to be. Now, in order to find angle T, I'm going to use law of sines. So I'm going to do the sine of T is to 53, because that's a side opposite, as the sine of 126 is to R. So whatever you get for this number, put it down right here. So in the end, you can cross multiply. So do the cross products, and you're going to use sine inverse because you're trying to find an angle measure. So this is an example of combining law of sines and law of cosines.